Ah. Okay, so Mendeleev's periodic table was based upon the repetition of the properties with increasing atomic mass, correct? When
Yes.
elements were arranged in increasing mass order, the properties of the elements had a periodic repetition. Had a periodic repetition. Okay, so Mendeleev perceived the idea that the properties of the elements are the periodic function of their atomic masses. Okay, so they were looking for criterion. Remember, anybody could classify, but the question is, they should be able to propose a classification. Supposing a new element is found out, then they should be able to analyze that new element and they should be able to propose in which group it should be present, correct? You
Yes.
already have some classification at your home. But
Okay.
supposing, say, or you already have a classification at your school, right?
Okay.
Like
Yeah.
so and so age, if the person has finished class 10, then he is
Mm.
allowed to go into class 11. That's a criterion. If he has
Mm.
completed class 11, then he will go to class 12. So there is some criterion. So supposing from India, one person X moves to Japan, then they will ask you, what class did you finish? So they want some criterion, right?
Yes.
To put him into class. Supposing this fellow says, see, I have completed only 8th standard. Then he will be put up in
Ninth standard.
9th standard. So that becomes the basis of putting the student into the class. So they were people from very early ages were able to see the similarities, but they were looking for a criterion and thinking what would be the criterion and why do the elements show the periodicity. So Mendeleev concluded that the properties of the elements are getting repeated when you arrange them in increasing order of atomic masses. So
Mm.
I move to first element, sixth element, 10th element, maybe the 11th element is similar to the first. So when elements are arranged in increasing mass order, he saw the repetition in the properties. Based on this, he proposed this expression, this statement. You can see the board, right?
Yes.
That the properties of the elements are the periodic function of their atomic weights. So until the Mendeleev's era, the atomic mass was considered as the primary property of elements and the periodicity in the properties was thought to be because of the elements arranged in increasing atomic masses. Okay. Now, the Mendeleev's periodic table was proposed. And as I said, there some of the places were left empty. Okay, because at that time Mendeleev did not have an element corresponding to that atomic mass and that property. So he left out empty places and he called the element to be Eka aluminium and he could propose the properties. He predicted the properties that the element would have atomic mass 68, would have density so much, would have low melting point, would have E2O3 type of oxide and ECl3 type of chloride. Later on, the element was found out to be gallium. They identified an element and they named it as gallium. And when the properties of the elements were analyzed, the properties were very, very close to what Mendeleev had suggested. So this became one of the greatest achievement of Mendeleev's periodic table. So he proposed yet to be identified elements and their properties also, which became probably a cue for identifying new elements.
Mm.
Okay. Now, as I told, up to Mendeleev's periodic table, the elements were arranged in increasing mass order, and the properties of the elements were thought to be periodic function of atomic weights. But later on, a number of spectroscopic studies started. You remember in the hydrogen spectrum, in the atomic structure, we
Mm.
were studying the hydrogen spectrum, etc. So when
Yes.
the spectral study started, people noticed something. What was that? in the year 1913, English physicist Henry Moseley observed regularities in the characteristics of X-ray spectra of elements. A plot of square root of frequency of the electromagnetic radiation found in the spectra gave a straight line when plotted against atomic number and not against atomic mass. That means the element which was identified was subjected to X-rays. Okay, and the emission spectrum was studied. The emission spectrum was studied. The emission spectrum is a line spectrum comprising of some electromagnetic radiation of certain discrete frequencies or certain discrete wavelength. So when the square root of the frequency found in the emission spectrum of the element was plotted against the atomic number. So when the atomic number was plotted against the square root of the frequency obtained in the X-ray spectral study, it was found to be almost a straight line. Okay, when the same thing was
plotted against
the elements were subjected to X-rays. Okay, and the emission spectrum was recorded. Emission spectrum is line spectrum. It comprises of some electromagnetic radiations, correct? And it is a discrete spectrum. You remember all that? Hydrogen spectrum, emission, absorption. Okay. So when the elements were subjected to X-rays and the emission spectrum was studied, the emission spectrum happened to be line spectrum comprising of some electromagnetic radiations of certain frequency values. Fine. ஓகேவா?
Yes, yes.
ஓகே. இப்போ இந்த frequency வேல்யூவோட ஸ்கொயர் ரூட்டையும் அட்டாமிக் நம்பரையும் y ஆக்சிஸ்ல frequency to the power half and x ஆக்சிஸ்ல atomic number plot பண்ணும்போது they roughly got a straight line. Whereas when they plotted the square root of the frequency obtained in the X-ray spectra of the element with the atomic mass or atomic weight, there was no clear line. Is it okay? It was an erratic behavior, something like this. So what happened? They thought that maybe the properties of the elements is not related to atomic mass. Instead, it is related to atomic number. So for the first time, they thought that let us shift our focus or let us shift our attempt to arrange the elements on the basis of atomic mass to atomic number. Clear? So instead of arranging the elements in increasing order of atomic mass, they started arranging the elements in increasing order of atomic number. Is it very clear?
Yes.
Okay. இது எங்க இந்த ஐடியா வந்தது? When the elements were subjected to X-ray spectral study, the plot of the frequencies obtained in the emission spectrum of the element versus the atomic number gave a clean, smooth line. Whereas when it was plotted against atomic mass, the behavior was erratic. It could not be explained. So since the frequency to the power half to atomic number is a smooth behavior, they thought atomic number probably is a better criterion to discuss elements rather than the atomic mass. Moreover, a single element like carbon had different atomic masses, right? Whereas the atomic number of both were same. And we know that carbon, whether it is carbon 12 or carbon 14, the properties are same.
Yes.
So it looked like atomic number is same, so the properties are same.
Okay.
And not the masses. So they started looking out for atomic numbers rather than the mass numbers. Are we clear?
Yes, yes.
Okay. So on the basis of all these observations, the law was modified. The Mendeleev's periodic law was modified. What did they do? They said that the physical and the chemical properties of the elements are periodic function of their atomic number. This time they started focusing on atomic number. Are we clear? Okay.
Yes.
Appo, when I arrange the elements in increasing order of yes,
First it was
Netra?
atomic. First it was atomic mass, and now it's atomic number.
Yes. Previously, up to Mendeleev's classification, the elements were arranged in increasing order of atomic mass. But for the first time, because of this plot, they thought that atomic number is a better idea, and they started doing that, and they saw that the arrangement became very smooth. Arrangement was becoming very, very clear. So they modified the periodic law and said that the properties of the elements are the periodic function of their atomic numbers. Whereas in the Mendeleev's classification, the properties were thought to be varying because of changing atomic weights. Clear?
Okay.
Okay. Okay. Thus the periodic, after the formation of periodic law, and moreover, by this time, it was around 1913. By the time this all happened, it was 1913. So by this time, many elements were known. All those elements could be arranged to more or less perfection according to the modern periodic law. So the modern periodic law still stands today, right? It's the classification which we still follow. Are we clear?
Yes, miss.
Okay. So based on that, the periodic law revealed important. Okay. Also, when you look at the periodic, the problem of isotopes, carbon 12, carbon 14. If I were doing Mendeleev's classification, then I should give the spot number 12 for carbon and spot number 14 again to carbon. But if I were doing the modern classification or the Mosley's classification, one single place is given to the carbon, which is the spot number 6. Are we clear?
Yes, miss.
Okay. Right. Okay. The periodic law revealed important analogies among the 94 naturally occurring elements. Neptunium and plutonium, like actinium and proactinium. Protactinium is also found in pitch blende, an ore of uranium. It stimulated renewed interest in inorganic chemistry and has carried into the present with the creation of artificially produced short lived elements. So, not only did they arrange the elements, the modern periodic law also prompted scientists to start producing artificially produced short lived elements. Why they are short lived? Because those elements are artificially made and they are very unstable. Since they are very unstable, they are very short lived. But at least this kind of study of the elements kindled the thought of maybe synthesizing new and new elements. Is it okay?
Yes.
Okay. Now, coming to, I'm going to give you this topic to do on your own, but I'm going to tell you what the periodic table. So, na solli kuttanu, then you can go and read it once. Now, the periodic table, which was generated based on the modern periodic law, is also called as the long form of periodic table, or it is also called as modern periodic table. Okay. So based on this, actually, if you browse into the net, a number of similar periodic table have been proposed time to time, but most of them are resembling the modern periodic table. So a modern version of so-called long form of periodic table of elements is the most convenient and widely used till today. The horizontal rows, which Mendeleev called series, are called periods, and the vertical columns, the groups. Elements having similar outer electronic configuration in the atoms were arranged in groups or families according to the recommendation of International Union of Pure and Applied Chemistry. You would have heard about this IUPAC in the last year. IUPAC nomenclature, yeah. The groups are numbered from 1 to 18, replacing the older versions of 1A to 7A, 8, 1B to 7B, and 0, etc. There are altogether 7 periods. So we'll go and see the long form of the periodic table. Okay. So the long form of the periodic table is this. Okay. In this, the elements having similar valence electrons are all placed together. That means lithium. Look at the outermost electronic configuration. They have given 2s1, 3s1, 4s1, 5s1, 6s1, and 7s1. So what is the similarity between all the elements? Can we say that their outer electronic configuration are same?
Yes.
Okay. So elements are grouped together based on similarity in the properties. And by now, when we write the electronic configuration, we know why. See, atomic number is also equal to the number of protons and is also equal to number of electrons. When we use the electrons and write the electronic configuration of, let us say, lithium and sodium, which is 2, 8, 1, people started seeing that the valence electrons of these elements are same.
Okay.
Whereas lithium's atomic mass is 7 and sodium is 23. They could not, if they still followed the Mendeleev's classification, they could not interpret why the element with atomic mass 7 is similar to the atomic element having atomic mass 23. Now they could clearly see that when they write the electronic configuration, elements placed in a vertical column will be called as a group. So we use the term group for the vertical column, and that means this is a group. Okay. And there are horizontal rows. What is a horizontal row? This is a horizontal row. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. This is horizontal row. And such rows are called as periods. So, in the modern periodic table, there are 18 groups. There are totally 18 groups and there are totally 7 periods. Is that okay?
So vertical it's and horizontal is
Vertical columns are said to be groups. There are 18 groups numbered as 1, 2, 3. Can you see where I'm going, where I'm marking?
yes, yes.
Yeah, 3, 4, 5, 6, 7, 8, 9, and goes up to 18. Whereas in the old form of the periodic table, that is, even in the Mendeleev's periodic table, the elements were arranged as group A and group B. I'll show you where they are. They were roughly arranged as group A and group. Yeah, see here. This side elements 2A, this side elements 2B. Okay, you see carbon is on the left of the group 4. Silicon is on the right. So they called it as the 4A, 4B. Vanadium in 5A, arsenic in 5B, and so on. So whereas all these things and the inert gases were named as group 0. Helium, argon, etc. But in the modern periodic table, the nomenclature of 1A, 2A, 3A, etc. is removed completely. You can see the group 7, group 8, iron, cobalt, nickel. At least highlight these 3 and I'll show you where it is. Look at these 3. Iron, cobalt, and nickel. They are present in the group 8 in the old periodic table, right?
Yes.
I'll show you that this is from the Mendeleev's classification. See, iron, cobalt, and nickel, and they are all present in group 8. So the Roman numeral numbers 0, 1A, 1B, 2A, 2B, all these are from the Mendeleev's classification. Whereas the IUPAC, International Union of Pure and Applied Chemistry, says that let us drop this 1A, 2A, etc. group 0 concept and let us just number the groups starting from 1 to 18. So there are totally 18 groups in the modern periodic table and there are totally 7 horizontal rows which are called as 7 periods. The period number 1 comprises of the hydrogen and helium. Period number 2 comprises of lithium to neon. Period number 3 comprises of sodium to argon and so on.
Mm.
So there are totally 7 periods. Are we clear?
Yes, miss.
Okay. Now, I told you the entire classification is based on the similarity in not atomic number, not the number of electrons, but number of valence electrons, correct?
Mm.
The elements present in a group are having similar valence electrons. So,
Okay.
based on this, the elements are classified into 18 groups. Now, if you say the group 18, in group 18, you will say helium is present. Helium alone will not have 8 electrons, but all others have got 8 electrons in the valence shell. Helium has got only 2 electrons. So, how is it possible for it to have 8 in the last shell? So helium alone has its K shell fully filled, whereas all other elements have 8 electrons. For example, helium's electronic configuration goes into K shell. Neon is 2, 8 going into K and L shell. Argon, it is K, L and M. It is 2, 8, 8 configuration. Likewise, krypton, like how if you just expand this Netra, you will be observing the electronic configuration similarities.
Mm.
Just see. This is leave the helium, but look at this. Isn't it 2s2 2p2 neon?
Yes.
And look at argon. Isn't it 3s2 3p2? Then
Yes.
4s2 4p. Sorry, I'm so sorry. I'm reading it as 2. It's 2s2 2p6, 3s2 3p6, 4s2 4p6. So xenon should have what?
5s to 5p.
That's all. So they have got same number of outermost electrons. The outermost electrons are in fifth shell. In the fifth shell, there are 8 electrons.
Okay.
In radon, it is sixth shell containing the 8 electrons. Organon is 118th element. Obviously, its configuration will be 7s2 and 7s. Clear?
Yes.
Similarly, if you see the halogens, the group 17 elements are called as halogens. These are the terms that you should know now. So group 17 are called as halogens. Group 18 are called as noble gases. Noble gases are unreactive gases, right?
Mm.
Or they are also because they are not reactive. No, they are also called as inert gases, right? They are also called as inert gases. Group 17 are called as halogens. The term halogen, you can break down, let us see if it is required there. Halo refers to salt. See, if I ask you to name a salt, tell me the name of a salt.
NaCl.
Very good, NaCl. So don't you find the chlorine in it, which comes from group 17?
Yes.
Actually, the word halo refers to salt and gen is to regenerate.
Okay.
So these elements are salt generators. So CaCl2 is the chloride salt of calcium.
Mm.
MgCl2 is the chloride salt of magnesium. MgF2 will be the fluoride salt of magnesium. So these are salt generators. That's why they are called as salt refers to halo and the gen refers to generate. Okay, so they are salt generators. So elements of group 17 are salt generators. Okay, elements of group 16 are also having a special name. Okay, for example, in your class 10, you would have studied some ores. For example, you've got zinc carbonate. When you do calcination, it is becoming zinc oxide, right?
Yes.
Iron is found in the form of Fe2O3, correct? Iron is found in the form of Fe2O3. Copper also, after it is converted to CuO, it is actually the extraction process is to convert Cu2s into Cu2O, and later on we do. So normally if you see these, they are all present in ores. They are ore generators. These elements are generally found with the metal in the ores of. So
Okay.
oxygen, sulfur, selenium, tellurium, polonium, etc. are called as ore generators, which is termed as chalcogen. Chalcogen. Chalco refers to ore, gen refers to generate. Clear?
Yes.
Okay. Now, what else here? There are some characteristic features of the modern periodic table. So that is what we should be aware of them. Na?
Mm.
We should be aware of them. So we are trying to become aware of the periodic table. Okay. We cannot memorize directly, or we need not memorize, I would rather say, but we will have to study as and when it comes. At least
Okay.
in class 11, you have to study the elements starting from hydrogen to zinc. That means from 1 to 30, you should definitely know.
Mm.
Plus, you be aware of the position of other elements in the periodic table. Fine? Okay. So we learnt about the inert gases, we learnt about the halogens, we learnt about the chalcogens, right? Now,
Mm.
the elements present in group 1 and group 2, if you just expand and see, their electrons are in the s subshell. Their outermost electrons are in s subshell. Correct? Their outermost
Mm.
electrons are in s subshell. For
Mm.
example, in the case of calcium, which is 40, the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So the outermost electrons of calcium are going into the 4s. Generally, the elements of group 1 and 2 receive their outermost electrons in the s subshell. And therefore, these elements, these two groups, are called as the s block elements. Okay, they are called as the S block elements. Is that okay?
Yes. Yes.
Okay. Now, going to the next one. Look at these. The S is completely filled. 2s2, 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 3s2, 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 4s2, 5s2, 6s2, 7s2. The S is completely filled, but this time the electrons are going into the p subshell. For example, if you see the phosphorus with the 15 atomic number, it's 1s2, 2s2, 2p6, 3s2, and 3p3. So, like how in the S block, the outermost electrons were going into the S in these six groups.
Mm.
That is group number 13, 14, 15, 16, 17, and 18. The outermost electrons are going into the P subshell. Therefore, these elements are also called as P block elements. The S block and the P block elements put together are also termed as representative elements. These are the names that you should be aware of, right? See, the representative elements are the S and the P block elements.
So together they're not representing.
Yeah. So, how many groups of representative elements are there? If somebody asks, what will be your answer?
8.
8. Is that okay? There will be totally 8 groups. Okay. Now, coming
Yes.
to the next part. Look at this. Now, you remember the N plus L rule. Na? The
Yes.
periodic table is a consequence of that. Periodic table is a consequence of your N plus L rule. Is it okay? So let us just take up the uh, elements and see where we can put them. Right? Okay. So if I'm doing, say, hydrogen, which is 1s1, then comes helium, which is 1s2. S is completely filled. In the first shell, do we have anything other than the S subshell? No?
No.
No. So 1s1, 1s2. That means how many elements can be present in the period 1?
Mm.
Only 2. The number of elements in a given period will depend upon the number of electrons going into the valence shell. So for hydrogen and helium, the electrons are going into the K shell only, right?
Mhm.
And the K shell comprises of how many electrons?
2.
And therefore, the total number of elements in the first period is only 2. So if you look at it, this number 1s1, 1 refers to period number also. Okay?
So the number of elements in a period depends
Yeah.
upon
Sorry, ma?
the number of elements in a period depends
Yes,
upon the
will be depending upon which subshells are filled up and how many electrons can be present. So my question, let us try this out. Let us find out in period 2 how many elements are possible. Fine. Okay.
6.
Will it be 6 or 8? Again, there is a lot of correlation between the configuration that we studied. In the first period, only the 1s is filled up. So in the second period, can you think of 2s and 2p getting filled up? Yes?
In the first period, 1s and 2s are both filled up, right?
No, it is not filled up. See, in the first period, only hydrogen and helium are there. That means, can we say it is only 1s getting filled up?
Okay.
What is the variation? It could have been 1s1 or it could be 1s2. If it is 1s1, it is hydrogen. If it is 1s2, it is helium. Got it?
Yes.
That's okay. Then coming to period 2. Period 2 will start with the filling of 2s, correct? So can we say that it is 2s1 and 2s2? The element with 2s1 is lithium. The element with 2s2 is beryllium.
Okay.
After that, even the 2p is filled up. So 2p means what? We will have to say 2p1, 2p2, 2p3, 2p4, 2p5 and 2p6. That means this 2p1 is boron, carbon, nitrogen, oxygen, fluorine and neon. So can we say that the number of elements in a period will depend upon how many subshells are getting filled up in that period? What are the subshells getting filled up? S and P, right?
Something.
What is the total number of electrons which can be present in S and P put together?
8.
8, na? So 8 becomes the number of elements in that period. Are we clear?
Okay, so the number of elements in a period depends upon the number of subshells that are filled and the
That the
electrons
number of,
present.
yes, the number of subshells that are filled and the number of electrons which can go in. So let us go to period 3, ma. Okay, let us go to period 3. So period 3 will have elements having 3s electrons, right? So it would be 3s1 and 3s2, which is nothing but sodium and magnesium. So 3s is over. Then comes 3p. That means it would be 3p1, 3p2, 3p3, 3p4, 3p5 and 3p6, which is nothing but aluminium, silicon, phosphorus, sulfur, chlorine, and argon. But you see, in the third period, there is 3s, 3p, and 3d. But it seems like the elements end with the filling up of the 3p6. I showed you the periodic table, remember? See, in the periodic table, look at the last element. Isn't it 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 5s2, 5p6? That means 3s is filled up, 3p is filled up, but not the 3d. Got it?
Yes.
Okay. Now, after this, so 3d is still available, na? We have not filled it up, correct? 3s is over, 3p is over. But do you remember the n plus l rule? Will the next electron go into the 4s or 3d?
4s.
Apo, the next element will be 4s1, 4s2. which would be potassium and calcium.
This is period 4.
Yeah, period 4. We have come to fourth period. One more very important and very simple fact. If you look at the shell number in which, so the maximum n value, the maximum principal quantum number is the period number as well, right?
Yes.
See, 3 maximum n value will become the period number. So what period is this month? Where it is 4s1 and 4s2?
Fourth period.
Fourth period, very good. So it is period 4. But there is something happening in between. What is that? After 4s, we fill the electrons where?
3D.
3d, very good. And how many electrons can enter into the 3?
4 electrons.
D contains how many electrons?
N miss.
10. Apuna, there should be in between 3D1, 3D2, 3D3, 3D4, 3D5, 3D6, 3D7, 3D8, 3D9, and 3D10. So up to 3D10, in between these two, we should be having elements, right? Okay, let me write it here. So this is 4P, 4D, 4F, 5S, 5P, 5D, 5F. What is the next after 3D? Check. What is the next after the 3D? After 3D, which is the 4D. Apona, are you able to perceive the idea that here it is 4s1, 4s2, then in between it became 3D, 1 to 10. Then again it is back to 4P1, 4P2, 4P3, 4P4, 4P5, 4P6.
Yeah.
Got it?
Yes.
Apo, in the period 4, which subshells are getting filled up?
Exception
4s,
and
4s, then
3D and 4P.
very good. அப்போ 4s ல எவ்வளவு electrons 2, 3d ல எவ்வளவு electrons 10 and 4p ல எவ்வளவு electrons 6. அப்போ total number of elements in the fourth period will be how many? 18. Are you able to see that? See? இப்போ புரியுதா ஓரளவுக்கு? The arrangement you are able to understand? Yes?
Yes.
Look at the arrangement. So in the first period, you have only 1s getting filled up, correct? In the first period, it is only 1s. So 1s1 and 1s2, right? 1s1 and 1s2. In the second period, it is the s. Sorry, I'll write it. In the period number 1, it is only 1s. In the period number 2, it is 2s and 2p. In the period number 3, it was 3s and 3p. But in the period number 4, it is 4s followed by 3d. Then comes 4. Okay? So you will find a total of how many? 18 elements because 18 electrons are going in. Is that okay?
Yes.
Okay. அப்போ இப்படி பார்த்தா கூட தெரியும்.
The third period, how many electrons will be this?
See, third period na என்னென்ன fill ஆகுது இப்படி பாரு. 3s, 3p, 3d. Then 4s, 4p, 4d, 4f. 5s, 5p, 5d, 5f.
Miss sound கேட்கல miss.
Yeah. See, இப்ப என்னன்னா இதுவும் பாரு 6d, 6f, இங்க 5g எல்லாம் இருக்குது. Okay. Then 7s. இப்ப பார்த்துட்டே வா. இப்ப 1s, first 1s fill பண்ணும்போது 2 electron போகுது. அந்த 2 electron containing elements are hydrogen and helium. Fine. Then 2s and 2p. The 2s and 2p containing orbitals or the elements are present in the second period. 2s and 2p. Is that okay?
Yes, yes.
Yeah, the group will start with the S only, no? A particular period starts with always S and ends at P6. Correct? So 2s2 and 2p6. Then in the next 3s and 3p6. It should start at S and it should end at P. So it will be 3s. Okay, 3s and here it is 3p.
It will be 8 electrons. 8
Yeah.
elements.
So it should start, any period will start with S and end with P. So அப்படி பார்த்தா 3s க்கு அப்புறமா 3p. That's the end of the period 2, period 3, na? Correct? Okay. மறுபடியும் அடுத்த பீரியட் எங்க இருந்து ஆரம்பிக்குது? 4s. கரெக்டா? 4s க்கு அப்புறமா நான் எங்க போகணும்? எங்க முடிக்கணும்? P ல முடிக்கணும். கரெக்டா? அப்போ P வர்றதுக்கு நான் ஃபர்ஸ்ட் 3D பெனிட்ரேட் பண்ணிட்டு 4p க்கு வரணும், ரைட்? அப்போ 4th பீரியட்ல என்னென்ன ஆர்பிட்டல்ஸ்? 4s, 3d and 4p, correct? Which will comprise of how many elements totally? 18 elements. Is that okay? I'll use which will have 18 elements. So here it is 8, here it is 8, here it is 2. Okay, next. இப்போ மறுபடியும் 5s ல ஆரம்பிக்கிறேன். எங்க முடிக்கணும்? 5p ல முடிக்கணும், ரைட்? S ல ஆரம்பிச்சு P ல முடிஞ்சிரும். அப்போ 5p குள்ள வரதுக்கு மறுபடியும் I have to penetrate the 4d, right? அப்போனா can we say this is 5s, then this is 4d and this is 5p, then again 18 elements. Understood?
Yes, yes.
இப்போ மறுபடியும் நான் again I'm going to start with 6s. If I start with 6s, where should I stop now? Any period will start with S and end with P. அப்போ நான் 4f முடிச்சிட்டு 5d ஃபில் பண்ணிட்டு 6p வரைக்கும் வரணும், கரெக்டா? So நான் 6s ல ஆரம்பிச்சேனா I have to go to 4f, I have to go to 5d and I have to come to 6p, right? How many electrons totally? 2 plus 14 plus 10 plus 6. That makes how many electrons? 32. அப்போனா 6th period will have 32 elements. But where are they? Let us see. The 6s. Okay. 6s க்கு அப்புறமா எதுமா fill ஆகுது? 4f. இந்த 4f எங்க இருக்குன்னா, see, look at it. இந்த 56th element க்கு அப்புறமா we are going to 57th element. And after 57th, you see 58th element. இங்க இருந்து பார்த்தேன்னா 14 electrons போகும். எதுக்குள்ள போகுது? I told you 6s க்கு அப்புறமா 4f, 4f க்கு அப்புறமா 5d, 5d க்கு அப்புறமா 6p. A period will start with S and will end at P. In between, in this picture, whatever orbitals are present will be filled up. So na 6s la ஆரம்பிச்சு 6p முடிக்கணும்னா I have to pass through 4f and 5d. So the order of filling will be 6s, 4f, 5d and 6p. Are we clear?
Yes, yes.
இப்போ என்ன ஆயிடுச்சுன்னா, these elements, இந்த elements பார்த்தேன்னா their outermost electrons are going into the F. இந்த elements பார்த்தேன்னா their outermost electrons are going into S. The elements are receiving electrons in the P. இவங்களுக்கு D ல. அப்போ இந்த element which is receiving the electron in F, should its properties be same as S, D, P or none of them? That is why if it's not similar to S, D or P block, therefore these 14 elements are placed separately in another section which will be called as the F block elements.
Okay.
Understood?
Yes.
சரி, அப்போ 6s ஆச்சு, இப்போ 4f ஆச்சு, அதுக்கப்புறமா என்ன ஃபில் ஆகணும்? 5d. இப்போ இங்க பாத்தீங்கன்னா 5d2, 5d3, 5d4, 5d5, 5d6, 5d7. So 5d fill ஆகுது. Once 5d is also filled, where will we go now? 6p. So 6p1, 6p2, 6p3, 6p4, 6p5, 6p6. புரியுதா இது? Okay, அடுத்தது. இப்போ மறுபடியும் we'll go back to that picture. இப்போ now I'm coming to 7s and I should stop at 7p, right? Very good. So 7p எங்க இருக்கு பார்க்கலாம். 7s, 7p, 7d. இது யூஸே ஆகாது. So 7sல ஆரம்பிச்சு நான் 7pக்கு வரணும்னா அதுக்கு நடுவுல எதெல்லாம் நான் பார்த்திருக்கணும்? எதெல்லாம் ஃபில் பண்ணியிருக்கணும்? வெரி குட். So 7sக்கு அப்புறமா 5f, அப்புறம்
6d.
வெரி குட். அண்ட் அவ்வளவுதான். அப்போ மறுபடியும் there are 32 na. So the 7th period will also have totally 32 elements.
Okay.
So first period la 2, second period la 8, third la 8, 18, 18, 32 and 32. Are we clear? இப்ப நீ இந்த you can start predicting the atomic number. 2 plus 8 பண்ணா 10 na? ரைட்டா? இன்னொரு 8 பண்ணா
16, 18.
18 plus another 18.
36.
36 plus another 18.
54.
54 plus another how much?
32.
Which is
86.
86 plus another 32.
118.
அப்போ உனக்கு புரியுதா ஏன் இந்த மாதிரி atomic numbers vary ஆகுதுன்ட்டு?
Yes, miss.
Okay, is that clear?
Yeah.
So supposing they are asking you that tell me the number of elements present in the 5th period. அப்போ memorize பண்ணலாம். அப்படி இல்லைன்னா நம்ம இது எழுதி பார்த்துடலாம். 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and 5s, 5p, 6s, and 6s. 5d, 5d, and 5f, then 6s. Now the question is, in the 5th period, how many elements are present? Upper 5th period will start with 5s and will end with 5p. Upper in between edella varudhu 5s kaprama 4d and 5p. So that means 5s, 4d and 5p. So 2 plus 10 plus 6, 18. How many elements are present in the 6th period? Abdina, it should start with the 6s, it should end with 6p. Right? So what are the subshells that we will fill up? 6s kaprama we will go to 4f, 5d and 6p. So 4f, 5d and 6p. A period will start with s and will end at p. So 2, 14, 10 and 6, which is making 32. So 6th period la 32. Are we clear?
Yes, miss.
Clear? Any problem in this?
No, miss.
Okay. So the elements are going to receive electrons in different subshells, and based on that we classify the elements as groups. So the group number 1 and 2 receive their electrons in the S subshell. So we call them as S block. இங்க என்னென்ன fill ஆகுது? இங்க S மட்டும் தான் fill ஆகுது. இங்க என்னெல்லாம் fill ஆகுது? P மட்டும் தான் fill ஆகுது. Outermost electrons are going to P. இங்க என்ன ஆகுதுன்னா P ல எலக்ட்ரான் போகுது, இவங்களுக்கு F. அதனால இவங்கள F block elements இல்லைன்னா they are also called as inner transition. Okay. S block elements, S block-ம் P block-ம் சேர்த்து representative elements சொல்லுமா? That D block நம்ம என்ன சொல்லுவோம்னா transition elements கூட சொல்லணும். ஏன் transition அப்படின்னா S block elements are proper metals, highly reactive, sodium, potassium. Why are they stored in kerosene?
To make sure they don't react with the air.
Or they are very reactive with the air. To prevent the reaction with air or moisture, we put it in kerosene. Correct? They are highly reactive. They are highly reactive metals. Okay. Fluorine is a highly reactive non-metal. So, if you look at the periodic table, the properties of the metal keeps decreasing and the non-metallic property keeps increasing. Appo, there is a change in the properties of metals to non-metals. Appo, or a transition. These elements bear the transition, the change. Appo, what can I call you? You are a child? Or are you an adult? You're a child. You are a teenager, right?
Sorry.
Correct. So the teenage is a transition between being child to adult. So it bears the transition. The transition elements bear the change. The metallic property slowly changing to non-metallic property through the presence of the D block elements. That's why they are said to be transition elements. Clear? Clear?
Yes.
அந்த டிரான்சிஷன் எலிமெண்ட்ஸ்குள்ள 57ல இருந்து 58ல இருந்து 71 எங்க இருக்கு? இங்க இருக்கா? 57 to 72 குள்ள இருக்கு. 58 to 71 இங்க வந்துருச்சா? அதே மாதிரி 89க்கு அப்புறமா 90 to 103 எங்க இருக்கு? 90 is here, 103 is here. So they are called as inner transition elements. They are hidden inside the transition elements. Inner transition elements. Is that clear? Okay. And in every group, how many groups are there? There are totally 18 groups. Right? All the 18 group elements bear similarities. So an element like boron will have similarities with aluminium, gallium, indium, thallium, and neonium. On what basis? They all have the configuration. See the now. Can I put it as NP1? Look at it. 2p1, 3p1, 4p1, 5p1, 6p1, and 7p1. Can I put it as NS2 and NP1?
For the P block elements.
No, but this is only for group 13 element, right? The NS2 NP1 is only for the group 13, correct?
Okay.
Okay. Similarly, for group 14, what can you say?
NS2 NP3.
NS2 NP. Okay, I'll show you. NS2 NP what? But NS2
NP2.
NP2. So can I say all these elements have got a fully filled NS?
Yes.
So I'll put it as NS2 and NP is varying from 1 to 6 in Solama. So this becomes the general electronic configuration of the P block elements.
Okay.
S block என்ன சொல்லலாம் பாரு? Can we say this is NS?
Yes. NS122.
Very good. So that becomes the general electronic configuration. For D block, it is very interesting. Say now ஒரு manganese எடுத்துக்க எழுதி காமிக்கிறேன். It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d5. Okay. Chromium என்னன்னா chromium abnormal electronic configuration ஞாபகம் இருக்கா? 3d5, 4s1. Titanium 22nd element 3d2, 4s2. அப்போ நம்ம என்ன சொல்லலாம்? இது N சொல்லிடலாம். Can I say this is NS122? ஏன் 1 to 2 சொல்றேன்? ஏன்னா குரோமியம்க்கு எவ்வளவு இருக்கு?
1 இருக்கு. Sல.
1. அதனால 1 to 2. But third shell, which can be called as n minus 1, right? D 1 to 10 ன்னு சொல்லலாமா? If the fourth shell is n value, then third shell will be n minus 1 value, na?
Okay.
Understood?
Okay.
இல்லையா? fourth shell நம்ம n ன்னு சொல்றோம். அப்போ third shell என்னன்னு சொல்லலாம்? n minus 1 ன்னு சொல்லிடலாம். அது இது என்னன்னா இது n minus 1 தானே 3ன்றது. If n is 4, அப்போ what is 3? Isn't it n minus 1? Understood? So the general electronic configuration will be n minus 1 d 1 to 10, n is 1 to 2. இந்த 1 to 2 கூட வெறும் அந்த குரோமியம் அண்ட் காப்பர் மட்டும், மற்றபடி அந்த எலிமெண்ட்ஸ்க்கு ஜென்ரலா இல்ல. சம் எலிமெண்ட்ஸ் லைக் ஆர்கோ திஸ் சில்வர் அந்த மாதிரி எலிமெண்ட்ஸ் ரொம்ப ரொம்ப ரேர். இப்ப நீ எக்ஸ்பேண்ட் பண்ணி பாரு, எங்கெல்லாம் அன்ஃபோர்சீன் எலக்ட்ரானிக் கான்ஃபிகரேஷன் இருக்கு பாரு. இங்க எதுவும் அப்நார்மல் இல்லைல்ல. 4s2 3d1, 5s2 4d1, 6s2 5d1. எதெல்லாம் அப்நார்மல் பாரு. டைட்டேனியம் குரூப்ல ஏதாவது அப்நார்மாலிட்டி இருக்கா? இல்ல. 4s2 3d2, 5s2 4d2, 6s2 5d2. வெனேடியம் ஃபேமிலியில இருக்கு. நியோபியம் பாரு. வெனேடியம் என்னவா இருக்கணும்? 4s2 3d3, but for niobium it is 5s1 4d4. So it is abnormal, right? Chromium ஃபேமிலியில chromium molybdenum abnormal. Okay. 25th ஃபேமிலியில எதுவுமே இல்ல. Iron ஃபேமிலியில ruthenium is slightly different. Cobalt ஃபேமிலியில rhodium is little different. Nickel ஃபேமிலியில one very very great difficulty is there. Palladium. Nickel வந்து 4s2 3d8. Palladium என்ன பண்ணுதுன்னா 5s0 4d10 வச்சுக்கணும். Okay. So in fact, you can also say it is 0 to 2. Owing to what? Owing to palladium. நம்ம ஜெனரல் தானே எழுதுறோம். அப்ப ஜெனரல் should cater to everybody, na?
So give me 1 to 10.
Tradition in the NS ல என்னென்ன சேஞ்சஸ் நடக்குது? Mostly NS is 2. In some places it is 1. In palladium it is 0ன்ற, which is very rare. Fine. So இந்த எலிமெண்ட்ஸ் எல்லாம் ஞாபகம் வச்சுக்கணும். இங்கெல்லாம் 1 எலக்ட்ரான் இருக்கு. So எவ்வளவு கேசஸ் ஆச்சு அந்த மாதிரி? 1 2 3 4 5 6 7 8 9 10 elements like so strictly bookல பார்க்கலாம் என்ன ஜெனரல் எலக்ட்ரானிக் கொடுத்திருக்காங்க அப்படின்னு. Look at the D block elements. தனித்தனியா இப்ப கொடுத்திருப்பாங்க. ஒரு குரூப்புக்கு ஒரு செட் ஆஃப் ப்ராப்பர்ட்டிஸ் இருக்கு. Okay, because obviously it depends upon in which subshell the electron is present, இல்லையா? In which subshell the electron is present. இங்க தனியா S block, P block, D and F block கொடுத்திருக்காங்க. So we look at the electronic organization. For the D block elements. See, can you understand now why 0 is included? Which element is responsible for that? Palladium has got the S0 and D10. Understood? So this is the general electronic configuration. Similarly, for F block elements. F block பார்த்தலாமா? ஒரு பார்த்தா தெரியும் உங்களுக்கு. We'll have to go to F block. We'll go to the F block and see. இங்க என்ன ஆயிடுதுன்னா, I'll ask you to do it. See here. In the 58th element இங்க தானே வரும். இதுக்கு ரெண்டுத்துக்கு நடுவுல 58ல இருந்து 71ன்றது இங்க தானே வரணுமா? ஓகே. இங்க ஃபர்ஸ்ட் என்ன ஃபில் ஆயிடுது? 6s ஃபில் ஆயிடுதா? இங்க வரும்போது 6s2 already will be filled. அதுக்கப்புறமா 5d1 இல்லைன்னா சில எலிமெண்ட்ஸ்க்கு 0 கூட இருக்கும் 5D 0 5D 0 சில எலிமெண்ட்ஸ்ல 5D1 அப்போ 5D 0 to 1 then comes your 4F பாருங்க 4F so 6s fill ஆயிடுச்சு 5D1 fill ஆயிடுச்சு அதுக்கு அடுத்தது 4F 1 to 14 fill ஆகுது கிளியரா இது எதுக்கு கான்ஃபிகரேஷன் F block எலிமெண்ட்ஸ்க்கு இப்ப இதை ஜெனரலைஸ் பண்ணி எழுதணும்னா இது என்னன்னு சொல்லலாமா ஹையஸ்ட் ஒன் இது என்னன்னு சொல்லலாம் n-1 ன்னு சொல்லலாமா இது என்னன்னு சொல்லிடலாம்
n-2
அப்போ the general electronic configuration will be n-2 F1 to 14 n-1 D0 to 1 and ns2 none of them have got 1 electrons in s so இதுதான் அதோட general electronic configuration clear-ஆ புரியுதா பார்த்தா புரியுதா இப்போ F block மட்டும் general electronic configuration பார்த்துட்டு we'll wind up with the class. What is the electronic configuration? F block n-2 1 to 14 n-2 F1 to 14 n-1 D0 to 1 and ns2 understood understood okay இப்ப என்ன பண்ணனும்னா you people can go through up to this trans uranium elements வரைக்கும் படிச்சிட்டு வரணும் இதுல என்ன நிறைய நியூ டர்ம்ஸ் வரும் ஏன்னா generally s block elements are more reactive they are highly electropositive they have got low ionization energy அப்படின்னு நிறைய ப்ராப்பர்ட்டிஸ் வரும் ஒரு தடவை படிச்சுட்டு வாங்க whatever you can't understand underline and read it. Is it okay for every group whichever term you are unable to clear ma'am I don't know what is oxidation state underline I'll tell you okay so every term what is meant by negative electron gain enthalpy அப்படின்னு இந்த லெசன்லயே படிப்போம் பட் யூ டோன்ட் நோ இட் இல்லையா அதனால யூ மார்க் அண்ட் கம் மேம் ஐ டோன்ட் நோ திஸ் கேன் யூ டெல் மீ ஐல் எக்ஸ்பிளைன் ஆல் தோஸ் டர்ம்ஸ் கிளியர் so up to trans uranium elements is that okay okay yes so I'll see you on again next Tuesday இங்க வரைக்கும் இல்லையா இங்க வரைக்கும் இந்த வரைக்கும் படிச்சுட்டு வரும் எக்ஸாம் ப்ராப்ளம் 3.3 வரைக்கும் படிச்சுட்டு இருக்கேன் சாரிடா n-1 D1 to 10 ns0 to 2 இல்ல சில இடத்துல நான் சொன்னேன்ல பலேடியம்ல என்ன வருது பாருங்க what is the palladium's electronic configuration அதுக்காக தான் அது 0 ஆயிடுது அந்த ஒரு எலிமெண்ட்னால தான் அது 0 let us see பலேடியம் பாரு எங்க இருக்குன்னு இதுல எஸ்ல எலக்ட்ரான் இருக்கா மத்ததோட கம்பேர் பண்ணி பாரு அதனால்தான் அது S0 so that's why we started writing as 1 to 2 but because of palladium we said it is 0 n-1 D 1 to 10 n is 0 to 2 clear okay இப்போ எனக்கு என்னன்னா next third அன்னைக்கும் இதே ப்ராப்ளம் தான் இருக்கும் I will not be available அப்போ instead can I take it on first the same time டிஸ்கஸ் பண்ணிட்டு எனக்கு மெசேஜ் போடுறியாமா உனக்கு ப்ராப்ளம் இல்லல
என்ன டே மண்டே கிளாஸ் இருக்கு மிஸ் டியூஷன் இருக்கு
மண்டே கிளாஸ் ஓகே டியூஸ்டே ஓ 6:15 தான் லேட்டஸ்டா அதுக்கு அப்புறமா வேண்டாம் வேண்டான்றீங்களா கிளாஸ்?
இல்ல அது டே பொறுத்து மிஸ்.
ஓகே. அப்போ எனக்கு மண்டே ஐ எம் ஃப்ரீ, நோட் இட் டவுன். அண்ட் ஃப்ரைடே ஐ எம் ஃப்ரீ. ஃப்ரைடே இருக்கு நான் பாத்துக்கிறேன். ஃப்ரைடே 5th மோஸ்ட்லி இருப்பேன், வீட்டில் தான் இருப்பேன். ஸோ ஒன்று நம்ம 6:15 எடுக்கணும்னா we can shift to 5th. அப்படி இல்லைன்னா எனக்கு சண்டே ஒரு ஃபங்க்ஷன் இருக்கு, போயிட்டு வந்துருவேன்னு நினைக்கிறேன். சண்டே கூட எடுக்கலாம்னு நினைக்கிறேன்.
மண்டே ஃப்ரைடே ரெண்டுமே டியூஷன் கொஞ்சம் லேட்டா போகும்.
ஓகே சரி. இப்போ வெனஸ்டே இந்த டியூஸ்டே ஒரு 7:30க்கா எடுக்க முடியாதா உங்களால கிளாஸ்? 7:30 to 8:30 எடுக்க முடியாதா?
8க்கு எனக்கு டியூஷன் இருக்கும் மிஸ்.
ஓகே 7 o'clock, 7 to 8.
7 to 8 ஓகே on Tuesday.
ஓகேவா? அதே மாதிரி we can maybe Tuesday ஆச்சா, வெனஸ்டே தான் முடியாது. Thursday also is okay for me. 7 to 8. 7 or 7:15 to 8:15.
7 to 8 will be okay miss.
ஓகே. அப்போனா நீ நோட் பண்ணிக்கோ. 26th இல்ல சாரி, தட் இஸ் 2nd அன்னைக்கு 7 to 8. அப்படி இல்லைன்னா 4th தான் நம்ம அங்க போறோம், அப்ப பெங்களூர் போறோம். ஃப்ரைடே முடியாது. சாட்டர்டே as such we have class இல்ல. ஓகே 6th இங்க தான் இருப்பேன் நானு. 7th தான் ஐ திங்க் ஐ வில் பி பேக். 7th அன்னைக்கு கொஞ்சம் லேட்டா வச்சுக்கலாமா? ஐ டோன்ட் மைண்ட்.
என்ன டைம் மிஸ்?
7th அன்னைக்கு உங்களுக்கு கிளாஸ் இருக்காதுல்ல.
எனக்கு
உங்களோட 7:30 கூட இஸ் ஃபைன்.
that's fine.
அப்போ எனக்கு இந்த 3rd நான் கண்டிப்பா எடுக்க முடியாதுமா. ஓகே, 3rd definitely not possible. And 7th Saturday, 6th I think I'll be available. Should not be a problem. The 3rd definitely not possible. நீ எனக்கு ஆல்டர்னேட் டைம், இப்போ உனக்கு தெரியும்ல வாட் இஸ் மை கன்வீனியன்ட் டைம் அப்படின்னு டிசைட் பண்ணிட்டு எனக்கு ஓகேவா?
ஓகே சோ மிஸ் நீங்க வந்து டியூஸ்டேவும் தர்ஸ்டேவும்
Tuesday, Thursday 7 to 8 is okay.
Okay.
Okay, or Sunday 7 to 8 or 7:30 to 8:30 is also fine.
Okay.
Okay.
So
மூணு நாள் ஏதாவது ஒரு நாள் எனக்கு பார்த்து சொல்லு. By maybe tomorrow you can let me know.
Sure.
Okay. Right. Okay. Bye bye.
Thank you, miss.